share my screen and I'll just start with the PYQ. Do stop me if there is something that is not understandable or something is confusing. Right, so let's start. So hopefully my screen is visible. Right?
Yes, sir.
Yeah. So this is the 2023 May term paper. So let's go through the questions. The first question obviously is something else. So this is the actual question. So here the question is, we are currently in a path which is /home/pinky, and then we do cd/where. So if we do cd/where, then obviously when we do pwd, then the path is /where. So then we have a for loop here. So for I in 1 to 10, do cd dash. So we know cd goes to the home directory, cd dot dot goes to the parent of the current directory, and cd any other name goes to that directory. But if we do cd dash, this means it goes to the previous directory. So not the parent directory, but wherever we were earlier. So for example, if I am in Pinky and then I go to where, then if I do cd dash, it will again go back to Pinky. Again, if I do cd dash, it will again go back to where. So it will keep on cycling like this. So you can see if I run it odd number of times, so if I run cd dash odd number of times, so it will obviously come back to where. Whereas if I run it even number of times, so it will end up in Pinky. So here we are starting in the /where, and we are running it from 1 to 10. So 1 dot dot 10, this will run 10 times. So it starts with 1 and ends at 10. So it will run it 10 times, and we are starting from where, and every odd iteration. So for example, when I'm doing just once cd dash, from where it goes to Pinky, and if I do two iterations, then again from Pinky it comes back to where. So every even iterations it comes back to where, and every odd iteration it goes to Pinky. So if I'm doing it 10 times, so the 10th time, which is an even number, it will again come back to where. So after this loop is done, then what is the current directory? So that is the question. So obviously, because we are doing it even number of times, we come back to where itself. So the answer here is where. So hope this one is clear. So if this was, let's say, 1 dot dot 9 or 2 dot dot 10, in that case, the answer would be Pinky, because we would be doing it even odd number of times. So let's move on to the next question. So here we have a lot of questions coming from this one main question. So let me also do it parallelly so that we can see how this works. So here right now I have no files or folders in a temporary folder. And here, let me also create these directory structure. So first we do echo 1, and we redirect that to a file called file1. Then we create two folders, dir1 and dir2. So right now we have file1, dir1 and dir2. Then we create a hard link. So ln without a minus s is a hard link. So we create a hard link to this file, which is file1, and name it file1.sh. So we do ln file1 underscore h1. File1 underscore h1 is the hard link. Then we create two soft links. First, both of them to so here we are writing ln minus s file1. So this does not refer to a file called file1 in our current directory, but this simply stores the path of file1 in this soft link. So when I save it this way, so if I do file1 underscore s1, this creates a soft link called file1 underscore s1, and that soft link contains the path, relative path, which is file1. So as long as this soft link is in a folder where in the same folder we have a file called file1, this soft link will point to that. So even if we change this file and make it some other file with the same name, still it will point to that other file. Right. So right now you can see we have this file1 in the same path. So that's why this file1 s1 is correctly pointing to this file1 in the same place. Then we are making another soft link. We are doing ln minus s file1 and dir1 slash file1 underscore s2. So that is another link we are making. So here notice that the link is created inside this dir1. So in this dir1, inside there the link is made, but the path stored in that link is file1. So this link will only work if inside dir1 we also have some file called file1, which we currently don't. So if I run tree, you can see that this link is a broken link, because even though it looks like we are telling this link to be linked to the file1 in our current directory, that is not how soft links works. So when creating a soft link, we should always either give an absolute path that will always work, or we give a relative path relative to the link itself. So relative to the link, it is trying to find a file called file1 in the same folder. So in dir1, it is trying to find, which is not there. So this link is temporarily broken. If we add some file there named file1, then it will be unbroken. Or if I move this symlink outside, then it will be unbroken.
So could you just repeat that a bit fast?
So when we are creating a symlink or soft link with dashes, so the path that we give as the first argument, that is, we're not telling ln to look at the file in this path and magically tie always to this file. So soft link cannot magically be tied to some file. It is only tied to some path. So what this does is it creates a symlink in the folder dir1 named file1 underscore s2, and in that file this path is stored. So this file itself contains this path, and it knows to always look for this path. So file1 underscore s2, name of this symlink, contains a pointing to a path of file1. So here this is a relative path, right? Because we have not given starting with a forward slash. So this is a relative path. So it is looking for a file named file1 in the same directory as the link. So inside dir1, we have this link, but we don't have any file named file1. So that's why this link is temporarily broken. If I create a file in this folder named file1, then this link will not be broken anymore. Or if I move this link outside of this folder, then it will again not be broken, because outside we have a file named file1. So that's till here. So let me create the other things also. So now let us go inside dir1. If I go inside dir1, you can see this link is still there, a broken link. So then what we are doing is we are copying the file1 in the parent directory here. So this is dot dot slash file1 dot. So if I do cp dot dot slash file1, so this means the file1 in the parent directory, and dot means copied here. So as soon as I have copied that file, so this is not linked or anything. This is a totally different file which has the same contents. So now that I have copied this file in here, so this file also contains a file called file1. So now you can see this link is no longer broken. So now this is no longer red, this is now green, and because it is now able to point to a file called file1 in the same directory. So then,
Red means broken link, sir.
yeah, red means that the link is broken. It's trying to access some file, but that is not there.
Okay.
So the colors might not always be there. So it depends on your terminal. So if you have a terminal that supports color, it will show it in this color. So here you can see that then what we're doing is we are writing the number 2 in file1. So we already wrote 1 in file1, which was in the parent. So if you see the outside file1 dot dot slash file1, that has 1. And if you see this file1 in the current directory, that also has 1, because we simply copied that file here. But now we are going to write 2 into this file1. So we write 2 in this file1 in the directory which is dir1. So we are inside dir1, and there we are writing 2 to file1. So now this file1 obviously has the value 2, and but obviously because this was just a copy of the outer file1, the outer file1 still has the value 1. So if I see the file1 in the parent directory, that still has the value 1. So now in this directory, we also have this link, right? File1 underscore s2. So this link points to this file file1. So because now this file's value has been changed from 1 to 2. So if I do file1 underscore s2, this will also say 2, because this is linked to this file inside the folder and not the file outside the folder. Right? So hopefully this is clear. So then we are creating other some other links also. So now we are doing ln minus s dot dot slash file1 underscore s3. So now notice that we are inside dir1 itself, and now the path that I'm storing in this newly created link file1 underscore s3 is //file1. So this will not point to the file1 in the current directory. This will point to the file1 in the parent directory. So you can see now file1 underscore s2, which we already had, points to this file1, whereas file1 underscore s3 points to the parent file1. So if I do cat file1 underscore s3, you can see this has the value 1 because the parent folder's file1 still has the value 1. And similarly, we create another link. So ln minus s file1. So this is again referring to the file1 in this directory in dir1 and file1 underscore s4. So you can see now the file1 underscore s2 and file1 underscore s4 both point to this file1 in the current directory. So this also, if I print the value, this also has 2, which is the value of this file1. Now, another thing we have to keep in mind is these links only just store the relative path to it. So right now, because we are in this configuration of folders, these are pointing to these things. If I move the file or if I move the symlink, then what it is pointing to will also change. So for example, if I have this file1 underscore s2 inside this dir1, which has in its inside it stored the path file1, so that time it is pointing to the file1 in the same folder. But if I move this link outside the folder, then it will automatically start pointing to the file1 in the parent folder. So it is not fixed to some file, it only stores the path to which it should point. And as long as there is some file in that path, it will point to that.
So if we put two absolute paths in ls-s, would
Yeah.
that create that link as a permanent one?
Yeah, if you put an absolute path, then wherever you put the link itself, the path will remain unchanged of the file. So it will always point to that same thing. But obviously, if you then rename the actual file or move the actual file, then the link will be broken. But yes, then it will not be like it will not change if you change the link itself, because we are giving absolute path in that case. So only if you're giving relative path, it becomes a bit confusing. So the last thing we are doing is then we are going out again into the parent directory. And then we are again creating a few copies. So we are creating copy of file1 inside the dir2, which is currently empty. And we are naming it file1. And we are copying this file1 underscore s1. So if you remember, file1 underscore s1 is a symlink which simply stores the path of file1 to it. So wherever it is, it will look for a file called file1 in the same directory. So we are then copying this symlink into dir2 as the name file1 underscore s5. So now what this does, this creates another symlink inside dir2. So if I do ll dir2, this will create another symlink in dir2 that it will copy the file, that is the actual file of that is pointed by this one. So we are copying file1 underscore s1. So as soon as I refer to this file1 underscore s1, it will refer to the actual file that it is pointed by, and it will copy that actual file into dir2 slash file1 underscore s5. So here you can see, although the name is s5, it is not actually a link, it is an actual file. Because when I'm copying, this link is already canonicalized. So when I am calling copy is not copying the link, it is copying the file pointed by the link inside this directory. So that is the pretext of this question. Then we have a few sub questions inside.
Shahid, can you just repeat that last bit, the copy part?
Yeah, so the last command here is copy file1 underscore s1 in the folder dir2 with the name file1 underscore s5. So file1 underscore s1 is a symlink that points to file1 in the current folder. But when I am copying, so the command cp, if I am giving it a symlink, what it does is it will canonicalize this symlink. So that means it will go to the actual path it is pointing to and copy that file and not the symlink
So
itself.
basically, file 1 is now copied as file 5.
Yes, file1 is now copied as file1 underscore s5 in the dir2. So currently the values are same as file1, but if I change one of the files, it will not be reflected in other because they are not linked. They are simply duplicate files. Okay, so now let's see the sub questions. So the first question is, what will be the output of cat dir1 file1? So if we do here cat dir1 slash file1, so we should remember that basically how the dir1 file1 was created. So first we made a file1 and put the number 1 in it. Then we copied file1 inside the dir1, but then we overwrote it with the number 2. So obviously the value currently in dir1 file1 is 2. You can see the answer is 2 here. So that's why the first question's answer is 2. So the next question here is, if we then, so another thing to keep in mind is these questions are unrelated. So when you're solving one sub question, you should not assume that the previous sub question thing has been done. So here what we are doing is we are storing the number 3 into file1 underscore h1, and then we are printing dot slash file1. So currently, if we see in the current directory, we have this file1 underscore h1, and this is same as this file1. So they are hard links. So if I do ls with an I, so you can see the inode. So file1 and file1 underscore h1 has the same inode. And if I cat the file1 underscore h1, you can see this has the value 1 because file1 has the value 1. So then we are echoing 3 to this file1 underscore h1. So this will change the value of both file1 h1 and file1. And then we are catting file1. So obviously if I cat the value of file1, I will also get the number 3. So the answer for this question is 3 because this is a hard link. Okay, so the next question is echo 4 into dir1 file1 underscore s1 and cat file1. So if we see, so let me tree it. So you can see in dir1 we have this one file1 underscore s1. Where is it? I think we forgot to make it ready once again. In dir1 we don't have any file1 underscore. Okay, we have this one, right? File1 underscore s. Okay. 1 second. Did we not make this while we were creating this? ln file. Okay, so in this, okay, we don't have a file1 underscore s1 in dir1, right? So we have this file1 underscore s1 that is outside. So here in this question, we are creating this new file. So we are doing echo 4 redirection dir1 slash file1 underscore s1. So this file is not there currently. You can see in here we only have file1, s2, s3, and s4. So we are making this now. And then we are asking what is the output of file1. So obviously just creating a simple file will not have any effect on some other file. So the like doing this has no effect on the output of cat file1. So the cat file1 will still remain the same. So here we are not assuming that we have done this previous command. So if you remember, we changed the value of file1. So the value of file1 became 3. But before that, the value of file1 was 1. So right now it will say 3. But if we had not changed it, so for example, if we had again set it back to file1 underscore h1. So then if we do cat file1, then the value would have been 1. So in this question, we have to make sure that we are not thinking that one option is executed after the other. So if we do this, so if we simply store the number 4 in this new file, then obviously the value of file1 does not get changed. So the value of file1 still remains 1 as it was originally when this question was created. Okay, and then we have this next question where we are echoing 5 into dir1 slash file1 underscore f3. So now this is a sibling that exists. So file1 underscore f3 exists, and it is pointing to the parent directories file1. So it's pointing to this file1. So when I'm echoing 5 into that, then this parent directories file1 gets changed. So if you see right now, if I do cat file1, it has 1. But if I do echo 5 and then redirect it to the dir1 slash file 1 underscore s3, which points to this parent file1. And if I do cat file1 again in the parent directory, you can see the value has changed because this symlink is simply pointing to this parent directory file1. So that has changed its value. But here we are printing the file1 inside dir1. So the file1 underscore s3 inside dir1 is not pointed to the file1 inside dir1. So it will have no effect on this file1. So this will still have the value 2. So if you see dir1 slash file1 had the initial value of 2, so it still has the value 2. So here the answer is also 2 because this file is not changed. And then we have this question where we are printing 6 to file1 underscore s3. So again, you can see that file1 underscore s3 is the same one for the last question, so which is pointing to the parent directory's file1. So if I do echo 6 into dir1 slash file1 underscore s3, and then what will happen is the value of the parent directory file1 is changed. So then if we cat that, cat file1, then the value is obviously 6. So this is why the solution for this sub question is 6. So these were the questions for this linking, soft link and hard link questions. Just let me know if all of these were clear. Okay. So basically the thing to keep in mind is that when we are creating soft links, either always to be safe, give the absolute path, or if you're giving the relative path, you have to make sure that you're not giving relative the path relative from your current directory, but it should be relative from the location of the link that is going to be created. So if you're creating it in the current directory, then it's easier to understand because it will be same as relative to your current directory. But if you're like, for example, here, and then you're creating the link inside dir2 or inside dir1, then the path you give should be relative to inside dir1 and not from your current directory. Right? And we can also see it like the value of the link will change. So for example, here right now you can see that file1 underscore s2 is pointing to a file1 in its same folder. So if I do cat file1 underscore s2, you can see that sorry, in the dir1, you can see that it's pointing to 2. But if we have a link with the same name pointing to the same thing, file1, in the parent directory, then that will point to this file1. So then the value of that will be 6 or whatever is the value of this file1. Okay, so let's move on to the next question. Okay, so in the next question, this is a question on awk. So the question is, which of the following commands will print the environmental variable home? So home is a variable in bash that stores the path of your current user's home, so which is basically /home / your user's name, unless you are root. So then it will be /root. So to print it inside awk, we can do it in multiple ways. So for example, if I am doing awk and then I am in the begin block itself, I am doing print $home. So this will work. This will okay. So this will not work because we have not put it in a quotation. So this will try to access the value of this variable. So this has been interpolated. So this becomes /home /cyan, but it is then given to awk. And if I just give some text to it, so for example, like this, so it will think of this as a variable itself. So it will try to print the value of this variable. So then it will print 0. So to print it as a string, we have to quote it. So for example, we have to quote it like this. So, but not with a single quote, with a double quote. So for example, if I quote it with a double quote, then you can see it's printing the correct thing. So if we, instead of hard coding this, if I now put $home, so now you can see this way we can print the value of $home. So this way, the awk itself has no ability of knowing what the variable $home is. This changing of $home into the value of $home is done by bash itself. So even before awk is called, this string has been changed into begin bracket open print escape quotes, then the value of $home, then escape quotes and bracket close. So when awk is called, it already gets this string which has the value put in, so it simply prints that. So awk has no awareness of this variable. So if I echo this also,
So,
so same thing.
so
Yeah.
outside single quote will not work, is it?
No, so that is the thing. So if you, for example, do echo home, this obviously works. If you do echo home with double quotes, this will, or bash will still expand the variable. But if you do it with single quotes, bash will not touch anything inside a single quote. So it
Yeah,
will
correct.
remain unexpanded.
Yeah, I was not talking about that. I was talking about the awk begin. Usually there also you have to, there. Yeah, that one.
Yes, yes. So if we are putting it inside this single quotes, right? So if I am telling print $home. So if I put it in single quotes, this $home is still inside the single quotes, right? So bash will not change its value. So it will go to the awk, the entire string will go as it is. So it will simply print the text $home.
Now, if you do a double quote, even that won't work because we need to escape.
Yeah, so if the outer ones are double quotes, then this will not work because this is basically this as a string and then $home and then this as a string. So we have to basically escape this quote. So you have to pass the quotes inside the quote itself. Sorry. So then it will work. So this is one way. So this awk is not accessing the variable. This bash itself is giving the variable to awk and printing. Another way is to use the this variable inside awk. So this is like a dictionary which can access any environment. So if I do awk and then here if I do begin and if we do like this print with the single quotes, if I put in single quotes and I run this, so this will not work because this single quotes is basically like ending of this single quotes. So it is becoming, this is one string and then this is one string and this is unquoted. So instead this should be in the double quotes. So this way also awk can print it, and this time awk itself is going to the dictionary and retrieving the value of the key home. So this one is done by awk itself and not by bash. Although the environments are obviously given to awk by bash, and that's why awk can access them through its internal dictionary. But the printing part is now done by awk. So we have 4 options here. The first one obviously is simply printing $home. And as we saw, $home will not expand inside single quotes by bash itself. So this one will not work. In the second one, what we are doing is we are printing using the environment dictionary, but here we are giving as single quotes. So the single quotes is ending here, so it's not quoting it correctly. In the third option, we are correctly using double quotes inside. So this entire string is going to awk, and this is also quoted correctly. So awk is able to print the environment variable home, its value. And in the fourth one, again, we are basically trying to use bash to do the interpolation, but obviously bash will not work inside the single quotes. So this will try to access a key with the name dollar curly bracket home curly bracket close, which is not some key existing in this dictionary. So this will ideally, I think, also give 0. So if we try to print this,
Sir, one doubt, sir.
yeah,
Is environ is it a keyword, sir, to get the
it's a dictionary.
It's a shell dictionary?
No, it's inside awk.
Okay.
Yeah, so it's a dictionary inside awk, just like we have other things like fs, nr, etc. Those are variables. This is also a variable which stores all the environment variables. So you can see it's giving an error because this is not expanded.
Because
So
it's
this is
not even in double quotes, it's not getting expanded.
yeah, that is there, and even if we gave it in double quotes and expanded it, so it would then try to print something in the dictionary with the key /home/username, which is not what we want. We want to simply print that value. So this would have been correct if we had used double quotes and escape double quotes inside, as we saw earlier. 1 second. Yeah, so this would have been correct way of printing it. Another way is this one, using the environment dictionary. So let's move on to the next one. So this is a very simple question. So here what we are doing is we are taking two commands and checking their exit codes and subtracting one from other. So the first one is a equals a and 1 not equals 2. So whatever be the value of a, even if a is undefined, the comparison a equals a will always be true. So if it's defined, obviously a equals a will be true. And if it's undefined, it will take empty string as its value. So empty strings equals empty string is also true. So this is always true. And 1 not equals 2. So 1 is never equals to 2. So this will also be always true. So true and true will also give us true. So this entire thing will return an exit code of 0. So V1 is 0. And the next one, so first one is using the test command, whereas the second one is using the bash keyword, using the double square brackets. So the difference is that we can use and directly inside instead of giving multiple brackets. So here we are checking the same thing, a equals a, and 2 does not equals 2. So we saw this part will always be true, but 2 not equals 2 will obviously always be false. So this entire expression is always false, and thus this will give the exit code of 1. So V1 is 0 and V2 is 1. So then we are simply printing V2 minus V1. So 1 minus 0. So the answer is 1.
Shayan, if equal to, I thought equals is equal to, right? Not equal to equal. Single equal to will work, is it?
Yes, in bash, inside this test command, you can use single equals to do comparison.
Otherwise, if okay, so anywhere it will work. Within a if also.
Yeah. So we don't put, so if itself does not have a syntax of checking anything, right? So we use with this special keyword itself, double square brackets. So this is kind of like a command that will evaluate this and return an exit code. And if only runs with commands. So we just give a command after if, and based on the exit code of that command, if decides whether to perform something or not.
No, my question is, will this a is equal to a? Will it also work for a string, or do we need double equals?
Yeah, it will also work for a string. So for example, if I here if I do, let's say apple equals apple. So you can see exit code is 0 if I do dollar question mark. Whereas if I do, let's say apple equals apples, then you can see that exit code is 1. So if I do echo,
Can you just do apple equal to double equal to apple? Will that also work?
yeah, that is also a correct syntax. So both are there, and this will obviously give you 0. And if you do with something that is not equals, it will give you 1. So equal to is there because most people coming from other languages will be familiar with this. So this is there for compatibility, but it is not absolutely necessary. So you can use single equals also.
Okay, thanks.
Yeah. Okay. So this is why the answer is 1 for this one. So next in this question, so we have the same command done in both VI and Emacs. So I'll be demonstrating it with VI. So Emacs will also work the exact same way. So let me first create a file like this. Let's say
This I
test.
think came in.
Yeah, it was in one of the quiz 1, right?
I think it was in quiz 1.
Some previous year paper. Still, like some might not have watched that session. So for sake of completeness, I'm
No, I
doing
was
it.
wondering if it came in our quiz. I'm not.
I don't think it was this time.
Okay.
It was like some previous year question. Okay, so here the question states that your cursor is in the first line, first character. So you're basically here on A, and then you are performing the following commands. So first is $, that means go to the last character of this current line. So it goes to the last character. So actually, let me turn on screen key also so you can see what I'm typing. Okay, so I will type $, character. So then the next thing we are typing is J and then DD. So J means move down one line. So cursor now comes on here, W, and DD means delete the entire line. So this entire line will be deleted. So we will only have the first line and the third line. So here if I do J, so now my cursor is here. And if I now do DD, that line is now deleted. So after that, we have K and then 0. So K means go up one line. So because this line is now not there, so we will go up to the first line, and 0 means go to the starting of the line, opposite of dollar. So if I do K and then 0, so now we are at the start of the first character of first line. Then we have DW. So DW means delete a word. So it will delete the word ABCD. So only thing left will be EFGH, IJKL, XYZ. So we also have the hints given here about what each character does. And the answer obviously is then this one, EFGH, IJKL, XYZ. Okay, so this is a question based on fill. Yeah. Okay, so let's move on. So in this next question, so let me close this. Okay, so we have a lot of commands here. So let's take it one by one. So we have SEQ 50. So SEQ or sec or sequence is a command that will print all the numbers from 1 to the number given. So if I do SEQ 50, it will print 50 lines. So for example, if I do SEQ 10, it will print the numbers 1 to 10. If I give it two numbers, so if I give it 5 and 10, it will print from 5 to 10. And if I give it three numbers, then if I give it, let's say, 5 to 15, so it will start from 5 and it will increment by 2 and it will go till 15. So you can see it's 5, 7, 9, 11, 13, 15. So do keep this in mind. The increment is not the third parameter for 3 parameter invocation. The increment is the second parameter for 3 parameter invocation. For 2, it's obviously just lower and upper, and for 1, it's just upper, lower being 1. And the upper bound is always included, unlike the range function in Python. In SEQ, upper bound is always included. And the lower bound by default is 1 and not 0. So 3 differences between range of Python and SEQ. So now here we are told we have SEQ 50. So this will obviously create 50 lines having the values 1, 2, 3, 4 till 50. So then we have this sed command where we are doing substitution. So what this is doing is it is searching for any digit. So this is the character class of digit. And this is inside a group. So as you can see, backslash bracket. So this is inside a group. So we are matching the group. And the search, so the search is any digit followed by \1, which means the same digit again. So this is searching for any number where same digit occurs 2 times. So how many such occurrences will be there in 1 to 50? A number where both the digits are the same.
11, 22, 33, 44.
4. Yeah, 4, right? So we have 4 such cases when this said substitution will occur. And what are we substituting it with? With just \1. So if we have a number with 2 same digits, we are substituting it with only that digit once. So 11 becomes 1, 22 becomes 2, 33 becomes 3, and 44 becomes 4. So we have a total of 4 substitutions here. And this set obviously starts from 1 to 50. So after the first command, we have 1 to 50 in 50 lines. After the second command, we still have 1 to 50, but 11 becomes 1, 22 becomes 2, etc. Then here we have sort n. So sort will sort.
There are 2 back references, right?
So the first one is when we are searching. So we are searching for a digit, then again that same digit. And then this is the replacement, right? So we have this /. So this is the replacement part. So we are searching for a digit present 2 times and replacing it with that digit only once. Right, so let us also see this so it will be clear. So for example, I'll do it with set 20. So it's easier to with set 20. So it's easier to see. So here we have 20 lines. And here if I do this, said I'll use Regex to make it easier to see. So we will group any 0 to 9. And I will search not only for any digit, but I will search for a number where that same digit is present 2 times. And I will replace that with that same digit. So if I do this, so you can see all of these are same, but 11 becomes 1. Right? So that is what this does. So if I make it sec 50 also, it will do it for those 4 things. So you can see 44 becomes 4, 33 becomes 3, 22 becomes 2, and 11 becomes 1. So now when we are doing sort n, so what sort will do is it will sort all the lines, and sort n simply means sort it numerically instead of alphabetically. So if I am sorting them, then everything remains as it is except these 4, 3, and 2, and 1, right, which we came out of substitution. So they will go to the top. So it will become 1, 1, 2, 2, 3, 3, 4, 4, and then everything else. So if we do this sort n, you can see all of these are there. There will be a gap here, 43, 45. Again, a gap here, 32, 34, and like this. And on top, we will have 2 1s, 2 2s, 2 3s, and 2 4s. So then we have unique here. So unique obviously removes all the duplicates which are adjacent to each other. So that's why if we want to remove global duplicates, we first sort it and then we do unique. So sorting always puts all the duplicates adjacent to each other. So after this, if I do unique, then obviously only the 4 numbers which were the effect of the substitution, which were duplicate, they were removed, and everything else remains as it is because each other number is unique. So then we are simply counting how many numbers there are. So we started with 50 numbers and 4 of those numbers were then duplicates. So 50 minus 4, we have 46 numbers. So if I do W3-LPF, we get the answer of 46. So that's why the answer here is 46. Right, so here the most important part is understanding which numbers exactly will be replaced here. So if we realize it will only be 4 numbers, so we simply subtract 4 from 50 and we get 46.
Sen, like if sec is equal to 100 is there, then what is the answer?
So if it's 100, then how many such numbers are there? There are 9,
Yeah.
right? So
Yeah.
11, 22, 33 till 99. So we have
Yeah.
9. So 100 minus 9 would be 91. So let's try that. So if
Yeah,
we
because
make,
in one of the paper it is written 90, so that's why, yeah.
okay. Yeah. So we also have 100, right?
Oh, yeah, yeah.
100
Okay,
has
okay.
100. So it becomes 10.
Yes,
So
yes,
10
yes.
is also then a duplicate.
I'm getting
Right.
91, that's why. Okay.
Yeah,
fine.
yeah, my bad.
Thank
I
you.
also made that mistake, right? So
Thank you.
100 also has like 2 digits consecutively. So
Yeah.
this also gets substituted to 10.
Yeah,
So
yes, yes.
that's
Thank you.
why. So if
Thank
I
you.
remove all this, then we can see that in action. So you can see this 99 becomes 9 and 100 becomes.
Yes, thank you.
Okay, so let's move on. So here we have a awk question. So here we are searching for some pattern which is starts with, so caret means starts with, 0 to 9 means a digit, dot star means any character any number of times, and then 0 to 9 star means a digit any number of times but also 0. So star means 0 or more, so it might be absent also. So what this means is any line that starts with a digit. So it may end with a number, it may not end with a number, it may not have anything else also, it should just start with a digit. So for all those kinds of lines, we are simply incrementing the value of this array in the key value, which is file name. So what is file name? File name is also an inbuilt awk variable that stores the name of the file that it is currently iterating over. So we can obviously give multiple files to awk, right? So for example, if we have these files. So if I do awk, and then here I simply do print file name. So if I run it only on one file, let's say file 1, it will only print file 1. But if I, let's say, run it on all the files, then you can see that the directories obviously give error, but for each other file, it will print the name of that file. And if you have some thing like this test, which has 2 lines, right? So then it will print 2 times because it is running for each line of that file. So here what are we doing? We are in the associative array, which has the key of file name. We're incrementing it. So we are basically storing a count of how many such lines exist for each file. So for each file, we are incrementing the count. Then after all the lines are like evaluated, in the end, we are running a for loop over all the keys in that file. And we are simply printing the key and the value. So we are printing the name of the file and how many such lines exist in each file. So what are the type of line that we are matching? A line that starts with a number and may or may not end with a number. So that are the options. So we have 2 options which are correct. One is the file name and count that includes the lines in the files that start with numbers. So this is true. and also the file name and counts that includes the lines that in the file that starts and ends with a number. So the ending with number is optional, it may or may not, but the starting is compulsory. So the option 2 is not correct because it says that file name and count that includes lines in the file that ends with numbers. So the ending is not compulsory. So starting is always compulsory. So you can see this here 0 to 9, it has to be there, whereas this 0 to 9 may or may not be there. And the last option is file name and
Why?
count.
Sorry, Shan. Why are you saying that? Just
Yeah, so
I can't
here
see it clearly. Yeah,
we
for
have-
starting is 0 to 9 has to be
Yes.
there.
Yes. And here it is 0 to 9 star, right? So star means
Okay,
0
star.
or more.
Okay.
So it can be 0 times also. Right, so that's why this one is true and this one is true, but second one is not true. And last one is stating that it should just have a number anywhere in it, which is also not true. It has to be explicitly, at least in the start. It can be also in the middle anywhere or in the end anywhere, but it has to be in the start. So that's why the last option is also not correct. So let's move on to the next one. So here we have some HTML file given to us, and our task is to print all the lines that is between the starting of the pre-tag and ending of the pre-tag. So if you don't know how HTML works, basically a tag starts with the name of the tag surrounded by angle brackets and ends with the name of the tag. On the right, it has closing angle bracket. On left, it has opening angle bracket and forward slash. So we want to basically print all these lines. And this question states you also want to print the lines that has the tag itself. So you also want to print this line which has font size and this line which has the pre and font. So the opening and closing tag along with everything in between. So this can be done in both sed and grep using the comma thing. So just like in sed, I can ask it to print 1, 2, so which means from line 1 till line 2, and ask it to print something and suppress default output. So it will print line 1 and line 2. So let me just create a file quickly. So you can see we have this numbers file which has 50 lines. And if I do something like sed 1, or let's say 10, 15 p on the numbers, then this will print only from line 10 to line 15. But this need not always be line numbers. We can also give regex searches in this as well. So I can tell, start from the line which matches the regex of, let's say, 12 and end at the line that matches the regex of, let's say, 18. So this will also work exactly the same way, and it will print all the lines in between, including those lines. So we are here using regex to match the starting and ending range. And for that range, we are specifying what the actions should be. So that is exactly how we will do this question also. So instead of matching 12 and 18, we simply match opening pre and closing pre with a forward slash. So that is the first option, sed -n, so suppress default output. And for the range where it starts with pre and ends with the closing tag pre, simply print all those lines. So this will print everything in between them, including those lines. So this second option is correct if the question asked us to print everything in between except the starting and the ending line. So why is this correct for that case? So obviously, if it is correct for that case, it is not correct for this current case. So why is it correct for that case? So here we are doing the same thing at first. So we are matching for all the lines that are in between pre and ending pre, including those lines. Then we are nesting that thing. So for all those lines, also match this query. So where this query is, it should not match this regex, which is PRE. So if I just do PRE in the forward slashes, this means match this regex. But if I do a semicolon, then sorry, if I do exclamation mark, then this means that the inverse of that match. And then again, we are another nesting inside. We are matching for all lines that are not the lines that has the ending tag of the pre. So this will match all the lines in between the two pre's, but not the lines itself. And then it will print those. So this is correct if we wanted to print everything in between except those. So for this case where we want to print as well, so in that case, it is not correct. And the third option would not be correct for that use case also, and is not correct for this use case also. So this is syntactically incorrect. So here we are basically putting both the things inside. So what we are doing is we are telling for the lines that matches pre and ending of pre. Then we are telling not matches pre till not matches ending of pre. So it can basically mean anything inside. So this will not do the thing what even the option 2 is trying to do. And this will also not do what option 1 is doing. So only option 1 using sed simply prints from pre to pre, including the lines. And option 2 will print everything except the starting and ending line. And we can do exactly the same way as option 1 using awk also. So the same syntax. So we do something. Yeah.
I'm sorry. That comma thing is the first time I'm actually hearing. How does that work? Sorry, you said it is basically from to two. Is it?
Yeah. So we have seen this with the numbers ranges, right? So hopefully this one we have seen.
Okay. It's the same thing.
Yeah.
Okay.
So instead of giving the number, we are giving the regex to search for.
Okay.
Yeah. So basically from matching this regex till matching this regex, all the lines, including those, will execute this command. So here the command is simply print that line. Similarly, instead of minus n and instead of p, I can give d. So only those lines will not be printed. So you can see from 10, 11, it goes to 19. So the action is totally up to us. But this way we can match on which lines to affect that. And similarly in awk also we can do. So here one thing we have to keep in mind. So is that if we just give a condition in awk without any curly braces, this implies we are printing that. So for example, here if I do awk, let's say 5, 10, so which means from line 5 to line 10. And here if I do, let's say print $0, and if I give the numbers, so okay, sorry, not this. So to match the regex, so if I give from the regex of 5 till the regex of 10, or let's say from 15 till 20, so you can see it prints only for the lines that match 15, 16, 17, 18, 19, 20. But here, so one thing we have to know is if we remove $0, it will still print $0. So if I just say print, it still means print $0. And if I remove the entire curly braces also, this also means the same thing as this. So this will also by default print those entire lines. But if I have the curly braces which is empty, then this means that don't do anything for that line. So then it will not print anything. So this is one thing we should keep in mind.
1 second, Shan. Can you just just wanted to note it down.
Yeah.
Sir, can you repeat that? Why third and the fourth options are not, not correct?
Yeah, so in the third option, we're not just seeing all the lines from the starting of pre till the ending of pre, but we're also seeing if that line does not match the that starting of pre line, and if it does not match the ending of pre line. So this will print only the lines in between. So it will only print these 3 lines, whereas the correct option will print the first line and the last line also along with these 3 lines. So here the question asks you to print that. So if the question asks you to print only these 3 lines, then this would have been a correct option and this would have been a wrong option. So depending on the question, the option is correct or incorrect. So here we are asked to print including those. So this is correct and this is incorrect. If we were asked to print excluding those, then this would have been incorrect and this would have been correct.
But how do we understand this comma here, sir? It is from to, right?
Yes, this part is from to. So it's starting from the line that matches pre till the line that matches the end of pre. This one.
We can also include other tags as well, like small.
Yeah. So whichever tag you want to search for. So
Ending
the
with
pre
small.
is not hard coded. Yeah.
Okay.
Yeah.
Shan, if you go back to your code syntax, last one, okay, you're basically because you put a bracket and given no instructions, it's not going to print anything.
Yes. So if you don't give brackets also, it will assume this. But if you give empty brackets, then it will basically not do anything. So a very simpler example would be like if I do something like nr is greater than 0, right? So this you can think is a way of emulating cat command. So this will always be true, nr is always greater than 0, and I don't have to even write this curly bracket print. This will just simply print it. So this is same as cat numbers. So you can go one step further. So instead of even depending on nr, you can do something like 1 equals 1. Right. So this statement itself will always be true. So for all lines, it will simply print as lines. So you can think this is a esoteric way of emulating the cat command.
Will is equal to 1 work? No, that will become assignment.
Yeah, I think in awk we have to use double equal to. Yeah, you cannot do 1 equals 1. If it was a variable, maybe it will still not throw an error. Yeah, so the variable assignment works, but so this is not equal to, this is assignment. So the assignment is then returning a exit code of true. So then it is working. But yeah, 1 equals 1 will not work. 1 double equals 1 will work. So let's move on to the next one. So in the next one, we have assume a large file with more than 1 million lines. So here basically what this question is trying to state is you have very limited RAM and you have a very big file. So you don't want to store everything in your RAM. You want to use as less memory as possible. And the question is which of these two scripts is more efficient on the memory? So the first script we can see for each line, it is storing that line numbers key in a dictionary called SEQ, and the value is the first column. So for each line, it is creating a new element in that array and storing the first column of that line as the value. Then after going through all the lines, in the end, it is then creating prev equals and empty quotes. And then it is going through all the keys for I in sec. And then it is seeing if sec of I is equals sec of I minus 1. So basically, if it's checking if there are two consecutive lines which are same or not. So if two consecutive lines are same, then it will increase the count. So count plus plus, otherwise it will not increase the count. So in the end, we are printing count. So this script is basically printing the number of consecutive lines that are same. But here, as you can see, this is storing the entire file in your memory using the dictionary. Whereas the second script, it is simply for every line, it is doing prev is $1. But before that, for those lines where prev equals $1, it is incrementing count plus plus. And in the end, we are simply printing the count. So here we don't have any other arrays or dictionaries. We simply have one count variable. And this is doing the same as the above one. So you can pause and think for a while why this is true. So basically, because we are only counting consecutive duplicates and not global duplicates, this can be done in a O of n time complexity, right? So as we are going through the lines, we can simply check that. So every time for each line, we simply check if the previous line was same as this line. If true, then we increase the count. If not, we don't increase the count. And either way, we then after doing that check, we then assign the value of previous to be the current line. So that when we are checking the next line, again, we can do the same check. So this way, we still have the same functionality, but instead of storing this humongous dictionary, we are only storing a 4-byte integer variable. So here, then the obvious question is, which one is more efficient than the other? And the answer is script 2 is more efficient than script 1. So script 2 is more optimal than script 1 in terms of memory. Script 1 is obviously not more optimal. And third option says both of them are same. So that is also not true. And fourth option says that script 2 is less efficient than script 1 because it has 3 blocks. So that is not true because even though it has 3 blocks, it is not using that much memory as the earlier one. It is only using one variable in its memory. So it is not less efficient.
Sir, how do you say that script 2 is more optimal, sir, compared to script 3?
There's no script 3 here.
Sorry, script 1 is more optimal than script 2.
No, script 2 is more optimal than script 1. Script 1 is not more optimal than script 2 because script 1 is storing this entire dictionary for all the line numbers, right? Whereas script 2 is not storing anything. It is only storing one integer. So if you have, let's say, 1 million lines of file, this will store around 4 million bytes of data in the memory. So each number will be 4 bytes and then 4 million of them. So 4 million bytes. Whereas this is, regardless of number of lines, it is only storing one variable, which is count. So this has way less memory usage than the script one.
Although both are achieving the same functionality.
Same functionality, yes. So the functionality is same. The approach of this one is a bad approach. So it is taking more memory, and this one is a good approach. Right. So let's move on to the next one. So we saw this one in one of the previous quiz 1 papers. So here we are basically matching MAC addresses using regular expression. And here the regular expression can be BRE or ERE also. So depending on the option, you have to decide whether it is BRE or ERE. So the question is, how do you match a MAC address? So same as we discussed for the quiz 1. So each MAC address, each digit, which is marked as X here, it can be 0 to 9 or capital A to F or small a to F. So that we can simply mention by putting it in this square bracket. So we can say 0 to 9, A to F, A to F. So that means 1 digit. And each of these groups has exactly 2 digits. So we can put curly braces, 2 curly braces to mention that such a digit has to be present 2 times. And then there should be a colon. So you can see there's a colon separating each group. So then we have a colon. And then this entire group is then present 6 times. So there are 5 colons and total of 6 groups. So what we have done is we have taken this entire thing with the 2 digits and the colon, and then we have grouped that. So you can see we have used round brackets and we have grouped that, and that we are repeating 5 times. So we are repeating this XX colon 5 times. And in the end, because we don't have another colon, so we are not repeating it 6 times. We are only repeating it 5 times. And after that, we are again doing the same thing. So 0 to 9, A to F, A to F, present 2 times. So this thing is all this till the last colon, and this one is the second last and last axis. So this is in BRE because we are escaping the round brackets and we are escaping the curly brackets. So this is in BRE. And
Shai,
these, yeah,
Shai, in the last the instead of 2, a curly bracket 2, can I use the back reference 1? Will that work?
no, if you're using back reference 1, that means the exact same group has to be there.
Ah,
So
okay.
we want any
Yeah, got
hexadecimal.
it.
Yeah.
But if let's say back reference was valid for some other situation, I would
Yeah.
have to use three backstrokes, right? One for the
No,
two
just one backslash is enough. So one backslash and then 1, that will mean that back reference 1.
Yeah, okay. Correct. Sorry.
Yeah. Yeah. So the second option is same as the first option. So instead of using the curly bracket 5 and like making the code smaller, we have simply mentioned the same thing 6 times. So you can see hexadecimal 2 times, colon, hexadecimal 2 times. So same thing we have written 6 times. And here we have not used the backslashes because this is in ERE. So this one is in BRE and this one is in ERE. So this is also a correct regex. So the third one is obviously not correct because as you can see here, we are simply saying any 2 characters, then a group and colon, and then any 2 characters 5 times. So the hexadecimal has to be exactly 0 to 9 or A to F and not any character. So any other letter also is not allowed. So that's why this one is incorrect. Similarly, fourth one is using digit, whereas hexadecimal can also contain A to F. So digit is not correct. So that's why fourth one is also incorrect in this. So if this was X digit, then it would be correct because X digit is also a way of mentioning 0 to 9, A to F, A to F. Right, so let's move to the next question. Okay, so here we are asking which of the following said commands will remove lines that starts with hash and empty lines from index.txt. So lines that start with hash basically means starts with a hash, and lines that are empty means lines that start and then end. So there's nothing in between. So caret and dollar signify lines that are empty. So here we have 3 options. So the first option uses the pipe without escaping the pipe, but sed by default uses BRE. So using the pipe without escaping the pipe will not work. So we have to actually escape the pipe. So that's why option 1 is incorrect, because we have not escaped the pipe, and option 2 is correct because we have escaped the pipe. And here we are basically using the regex itself to tell that either this or that. So I'm telling starts with hash or starts with end of line, and then drop those lines. So for lines where either of these regexes match, drop those lines. And in the third option, we have basically split it into two said commands. So two said actions inside the same command. So we're telling for lines that start with hash, drop them. And then again, another command we are telling lines that start with end of line, drop them. So this will also do the exact same thing. So here we're using regex or to mention two things, and here we are having two statements to the same set.
So to separate the two statements, we're using semicolon, is it, sir?
Yes. So if it's in a script, you can put them in a separate line. If it's in single line, you can put semicolon to separate them.
Or finish one set and minus E.
Yes, yes. Or you can put minus E and then this in quote, and then again minus E and again this in quote.
But will that first remove, it will do it sequentially, right? First it will
Yes.
remove all this thing, then in the remaining, it's almost like piping it into the next
No,
one.
no, no. It'll do for each line. It'll do the first statement, then the second statement.
Okay.
Yeah. So it's not like piping. It's like this one only. So it'll do the same as this one. Third option. So for each line, it will do the first command, then it will do the second command or statement.
Okay. Okay.
Yeah. So let's move on to the next one. So here the question is a bit confusing. So the question states, which of the following commands can delete leading and trailing white spaces from each line of the file sample.txt? So white space usually means either the space or the tab symbol. So the options itself are pretty simple. So what we are doing is we are searching for the lines that either starts with white spaces or ends with white spaces. So you can see if we have any line that starts with either a space or a tab, so we have put them in the square brackets. So either it is a space or it is a tab, and there are 0 or more of them. So we simply substitute them with nothing. So we are simply removing the starting space and tabs. And as you told in the last one, right? So we can use minus E to separate multiple statements. So then we are also doing this check. So this was for starting, and then we are checking for ending. So if it ends with one or more space, then we are replacing that with nothing. So here in the ending, we are only checking space, whereas in the starting, we are checking space and tab. So if there are one or more spaces in the end, then we are substituting that with nothing. And if there are one or more space or tabs in the starting, then we are substituting that with nothing.
Since it's a single, since it's a single space, we are not enclosing it with a square bracket.
Yeah, exactly. You can put it in square brackets, but you don't need to.
So, Shayan, in the first one, which is
Yeah.
tab 1, we are
Yeah.
looking for a space and a tab.
A space or a tab. So,
Space or a tab. Yeah,
yeah.
space or a tab. And this one, we are just saying any number of spaces, but towards the end.
Yes. So this is also any number of space or tab at the start.
Correct.
This is just space. And in the second one,
Tab will not be interpreted as a space, is it? Because tab is 8 spaces, right? Roughly, or something like that.
no, tab is itself a different character. So some editors convert your tab into 8 spaces or 4 spaces, but tab itself is a separate ASCII character.
Okay.
Yeah. So in the second option, we're basically using the control class, which is a space. So this matches space, tab, all those. So this is arguably a better solution than the first one, but both of them work. So this one will search for 0 or more spaces at the start, and then 0 or more spaces at the end, and substitute them with nothing. The same
Here-
as
Here we are not using tab at all, right?
So tab is included in the space class.
Okay.
The space class matches all white spaces. So the space character, the tab character, all of them are matched in this.
Okay.
So in the third option, here we are using gsub inside awk. So gsub is basically a function that will do same as said substitution. It will do it globally. So in this gsub, we are searching for the regex, which is either starts with space plus, which means one or more space, or space plus end of line. So either starts with one or more space or ends with one or more space. So for all those matches in $0, so if we don't give it the third argument to gsub, it takes $0 by default. So in $0, if there is any pattern which is starts with one or more space or ends with one or more space, then it will substitute those with the empty string. So it will simply remove them. And then we are printing each line.
And then the obvious question is, what about tabs?
Yeah, exactly. That's why I said this question is a bit confusing. So here, basically, what we're doing is in some options we are matching space and tab, and in the same option we are matching only space at the end. And in this option we are matching space and tab in both front and end. And in this one we are only matching space. Right. So
Basically, white space does not include tab.
no, white space includes both space and tab. So the like interpretation of this question might be a bit confusing. So what this exactly wants you to select. So does it want you to only select this one or all the three, because they are removing white spaces. So this is removing all the white spaces, whereas this is removing some and this is also removing some. So that interpretation is a bit confusing, but all of them are doing.
Why is it? The first one is removing tab and spaces, right? So it's removing all white spaces.
Tab and spaces at the front, but only spaces at the end.
Ah, okay.
Yeah, and this one both at both the sides, and this one's only space at both the sides. And the last one is obviously incorrect. So we are simply catting the file to xargs. So without giving anything to xargs will obviously error out and it will not do anything.
But sir, when third option, I'm still getting confused, like, because it is not taking the tab.
Yeah, so here we are only replacing the spaces at the start and end. We are not replacing the
Even
tabs.
then, it's a right option in this case, is it?
Yeah, so that depends on the interpretation of the question. So if you interpret this as it should replace all white spaces, so both space and tab, then only option 2 is correct. But if you interpret this as replacing any white space, either like space or tab, then both option 1, 2, and 3 are correct. So these are what the options are doing. And the fourth one is always incorrect. Okay, so let's move on. So this question is a simple question. So it's based on the sleep command. So it states that you're running these commands. So how many background processes will still be running after 5 seconds of execution of the script? So here the echo and echo 2 and echo 3, this line anyway does not matter to us because they will be instantaneous. The only important ones are the sleep ones. So if we had this without the ampersand at the end, so if we ran this without running it in background, then these would be blocking. So sleep 1 will block the terminal for 1 second and only after then sleep 6 would run. But because we have them all with ampersand, all of them are running in the background.
Hectic.
Yeah, so everything is running in the background. So all of them start at the same time. Yeah, can you mute if you're not asking something?
हाँ मैं जानती हूँ बहुत ज्यादा बिजी शेड्यूल होता है तो फिर हम दोनों ने ऐसे
can you-
खुद को तसल्ली देने के लिए इतना करारा
Sapna,
जवाब
can you
सुनने
mute yourself?
को नहीं।
We can hear you.
Yeah. Okay. So here basically you can see that we have put ampersand at the end of all of them. So all of them will start executing at the same time. So after 5 seconds, obviously after 1 second the sleep 1 would have finished, and after 5 seconds, so after 2 seconds sleep 2 would have also have been finished. So after 5 seconds only the sleep 6 and the sleep 12 would still be running. So here the answer would be 2 because we only have 2 commands which would still be running in the background, and sleep 1 and sleep 2 would have finished before the 5 seconds. So let me just draw this also how this would be. So if let's say this is t equals 0 when that script has been started, so the sleep 1 will run and finish at 1 second. The sleep 2 will also start at the same time and it will run and finish after 2 seconds. So this is 2 seconds. And the sleep 6 will run for 6 seconds and it will end at 6 seconds. And the sleep 12 will end at 12 seconds. So at the end of 5 seconds, the sleep 1 and 2 has already finished, whereas sleep 6 and 12 are still running. So that's why there are total of 2 background processes after 5 seconds.
Shad, a couple of questions on this one.
Yeah.
So let's say there was no ampersand for now, right?
Yeah.
When I
yeah.
say sleep 1, it
Yeah.
will, after sleep 1, it will go to echo 2.
Yes.
After
yes.
sleep, after 1 second, it will print.
Yes.
The moment you say and, what does it mean? It goes into the background.
Yes.
Okay. So echo 2 comes immediately, it runs echo 2, echo 3 also, whatever the second line also runs immediately.
Yeah.
Then it's running in the background, is it? Is that what, does that what it means? One and, or is it suspended?
No, it's running in the background. It's not suspended.
Okay.
Yeah.
So and itself is meant as running in the background.
Yes.
While
yes.
the process is sleeping, do the other task.
Yeah, the process is not sleeping. The process is running. It is running in the background. It's not blocking the next tasks or the next commands.
Which one is the one which you suspend, Shayan?
You suspend with Control Z. So if something is in the foreground, not in the background, if something is in the foreground, only then you can suspend. So for example, if I do sleep 100, this is blocking my terminal, right? I cannot write anything, run any command. If I do Control Z, then it is now stopped. So like the timer itself has stopped. So let's say it did only 5-6 seconds. So it's still waiting for it to resume. So even after 100 seconds, this would not have finished because it is now paused kind of. So if I want to resume it, I can either resume it in the foreground by typing FG. So again, it will block my terminal. So again, basically, if X seconds have passed, 100 minus X seconds, still it will run. But if I do Control Z again it is stopped. So instead of FG, I can do BG, and then it will resume, but in the background. So now my terminal is free for me to run anything, but this is also running in the background. So after 100 seconds, this will stop and it will not exist anymore. But it is running in the background. So here also you can see the ampersand is used to signify that it is running in the background. So if I run something directly with the ampersand, so then it will also be run in the background. So then we don't have to use FG or BG.
Typical, say in a typical batch job scheduling aspects, where there is no dependency, we'll keep the jobs running in parallel, right? In that case, I can use
Yeah.
ampersand.
Yes, exactly.
So could you go back to the diagram which you have drawn?
Yeah.
Here okay, we have till 12. Okay, so thank you.
Yeah. Okay. So that is the last question of this. So this is some other subject.
Shayan,
Yeah.
I have some questions from a past paper. If you don't have a plan to show something else, can I just quickly ask you one or two doubts?
The thing is, I have another meeting right now. So is it fine if we take it up tomorrow?
Sure, sure.
Yeah. Okay. So that's all for this paper. So 2023 May paper. So if you have any doubts, just note them down and we'll discuss
Shayan,
it.
one favor, I don't know, because you also have an exam on Sunday, obviously.
Yeah.
But if maybe we'll do it over OPP, if we can't do it now, I'll just take 10 seconds, which is if you take one of those MAC addresses or phone numbers or any of these pattern, right? So where one, let's say one of them will have to repeat.